Hello, this is Aaron Hildebrand.
I'm Caleb Horton.
This is our enrichment project for DNA replication. I will be voicing.
And I'll be drawing.
Okay, first, in the DNA replication fork, the helicase goes along and splits the hydrogen bonds between the nitrogenous bases. So, they all get split apart so they can be copied. DNA gets copied in 5 to 3 prime, like so. The top strand is called the leading strand, and that one's easy to copy because it goes from 5 prime to 3 prime. But the bottom strand is called the lagging, and that one's very difficult to copy because it has to go 5 to 3 prime, but it's going in the opposite way that the helicase is breaking apart the DNA fragments. To start off with the leading strand, it's so easy because the polymerase 3 just follows the helicase and just puts the corresponding pieces of A, T, G's, and C's onto the nitrogenous bases. What's so difficult about the lagging strand is that first, RNA primer has to go down and put a primer of RNA so DNA knows where to start. Once the primer goes down, a polymerase 1 comes along and changes the RNA into DNA and a section, so that's no more DNA. Then the polymerase 3 comes down and starts going backwards and replacing, it does the same thing as the lagging strand. So it's going that way, and so that's the polymerase 3. But it's going to run into DNA that's already been copied because in the replication bubble there's 2 replication forks on each side of the bubble. So instead of it's going to go over DNA it's already been copied, so then the DNA ligase comes in and it snaps all the pieces of DNA together that have been made with the RNA primer being replaced and the polymerase 3. This is it. This is pretty simple if you know what everything does. This has been our video for DNA replication.
I'm Caleb Horton.
I'm Aaron Hildebrand. We're signing off.